Okay, G, we are going to do the past papers of turning effective forces. So in this particular chapter, we have question number one. So in question number one, we have a diagram shows a balance being used to find the weight of a baby. The weight of the basket can be ignored. This is the basket. It can be ignored. At equilibrium, the pivot is near to the weight W than to the baby. Equilibrium means like there is no further rotation. This is called equilibrium. What is the weight of the baby? So remember this thing, like what is the formula for movements, like principle of movements? It means like F1 D1 equals F2 D2. If I take it like F1, so D1 would be the distance of this load till the pivot point. So what is this thing? This is called D2 till here, and this is what F2. So over here अगर आप देखें तो the distance D2 is large, the distance D2 is bigger, so F1 should be smaller, and if you see D2 is smaller, so F2 should be bigger. So examiner is asking like this F2 is what, this is W, this F1 is what, the weight of baby. So weight of the, like where W is bigger, the weight of the baby will be smaller. So what is the weight of the baby? It is less than W. So the answer would be A. So in question number two, we have the diagram shows a handle with three forces, each 100 newtons applied to it. The handle is free to move. What is the effect of the forces on the handle? Now, in this particular situation, we should know like whenever a force is acting on an object in such a way, like line of action of force is passing through the pivot. This is actually a pivot point. So pivot is the point about which the rotation would occur. If this is passing through the pivots, it is not going to produce any moment, so I will ignore this force. Now there are two forces. If we talk about the 100 which is acting rightwards, so it is going to produce the clockwise moments. How do we know like it is going to produce the clockwise moments? We have to neglect all of the rest of the forces which are acting. For example, if this is 100 Newton force, this is 100 Newton force, we will totally ignore them and we would just focus the force which is to be considered. Like for example, if I'm talking about this 100 Newton, this is the only force acting. I will leave rest of the forces. So this is 100 Newton force. If we see this is the distance d, this is the smaller distance. So it means like clockwise movements produced are smaller as compared to anti-clockwise movements because this has the same amount of force, but over here it is 100 times the bigger d. The distance is bigger. So it means clockwise movements are smaller and anti-clockwise movements are bigger. So the handle will move in an anti-clockwise direction to the left. So the answer will be C. Okay. If we talk about question number three, so in question number three, we have the diagram shows force being applied to a lever to lift a heavy weight. Which change would enable the heavy weight to be lifted with a smaller force? Now, if we just want to see like what is the movement produced with the help of this load, is the weight of the load being multiplied by the distance. We cannot change the position of this load. If we want to make it easier, like smaller force, if the force is smaller, the distance applied should, the distance at which the force should be applied, that would be bigger. So we have to move this force to the left. So move the force to the left, to the right. No, this is not the right answer. Move the force to the left. Yes, this is the right answer. So the answer would be C. Move the pivot to the left. We cannot change the pivot. Pivot is actually a fixed point about which the rotation would occur. This is actually a fixed point about which rotation occurs. Clearly? Okay. Now, this is question number four. A wooden bar is pivoted at its center so that it can rotate freely. Two equal forces F are applied to the bar. In which diagram is the turning effect greatest? If we start discussing it right from the point like part D, so these are the equal distances. If you see this is distance D, this is distance D, so these are the equal distances. The upper force is going to produce clockwise moment. This force is going to produce anti-clockwise moment. So clockwise and anti-clockwise moments are equal because the distances are same. So it is not going to produce any moment. So it would be in equilibrium. If we talk about this, so the same thing happens here. This is going to produce equal moments because the forces are same, the perpendicular distances are same. So they are going to be in equilibrium as well. If we talk about B and A, now it's a bit confusing. So if this is pivot, if I'm going to take this distance as D and this distance as D as well, so they are going to produce anti-clockwise moment. So the moment produced by this force is Ft, and the moment produced by this force is also Fd. Because both are in the anti-clockwise direction, so sum of moments would be equal to 2 times F into T. So this is taken to be the larger one. Why we are not taking the B as an option? Because it is the largest distance, like this is the biggest D. But if we talk about this force, this has a smaller distance from the pivot, which means let's suppose it is D by 2. So it would be F times D plus F times D by 2, which is going to produce what? Fd plus 0.5 Fd, which is going to produce 1.5 Fd. So this is sum of moments. It is the smaller value. This is the bigger value. I locked option number 8. Clear? Now, let's move to question number 5. The diagram shows three uniform beams. Uniform means like their thickness is same, their material is same. P, Q, and R, each pivoted at its center. The two forces acting on each beam are shown. So which beam rotates clockwise, which would have a bigger clockwise moment. It doesn't matter which force is bigger. It has nothing to do with. We have to see the product of two things like force as well as distance, the perpendicular distance from the pivot. If I'm talking about this one, so what are the anti-clockwise moments? Like 4 times 2. 4 times 2 is what? It's 8. 8 anti-clockwise. What is this? 4 times 1. 4 times 1 is what? Clockwise. So this is clockwise, this is anti-clockwise. He was actually asking about the clockwise one. So I'll forget this option. Let's talk about option number Q. So this is 5 times 2, which is going to produce 10 clockwise. This is what 2 times 4. So 2 times 4 is going to produce 8. It means like this is a smaller number as compared to 10. That's why right hand side movements are taken to be more. It means like clockwise movements are bigger here. So obviously Q is an option. So P is totally neglected. Q is an option. This is neglected, and R option. This is because rest of all are wrong. I have to take it C, but I'll confirm like rather it is right or wrong. So let's talk about R now. So it is going to produce a clockwise moment. So what it would be, it is 4 times 1. It is going to produce 4 Newton meter. And this is what? 1.5 times 2. It is going to produce 3. So the clockwise moments are 1 Newton meter more as compared to anti-clockwise moment, which was actually 3. So this is the confirmed like this answer was taken as right answer. Okay. Let's do question number 6. The diagram shows a non-uniform beam of weight 120 newtons pivoted at an end. The beam is kept in equilibrium by a force. What is the force F? Now see, this weight is going to produce a clockwise moment. We have to take this thing as a pivot point. So if I am going to release this beam, it is going to produce a clockwise moment. If I just take it this way, like for example, this object was taken in this particular situation, and I am going to take it this way. So this will be rotated. Like for example, this is not a situation. For example, if it was able to rotate, for example, this was the situation. This was the beam actually. So with the help of 120 Newton load, it has to be rotated this way. This way. So 120 की वजह से ये clockwise है. What about F? F की वजह से ये anti-clockwise होगी. So which means 120 times 20 centimeters are going to produce clockwise moments. These are clockwise. And what would be the anti-clockwise ones? So this is the force F being multiplied by the perpendicular distance. Now the students normally take this value as a perpendicular distance, but this is not the right answer. We have to take the perpendicular distance all the way from the pivot till the force. So it is going to be 80 centimeters. So this is F times 80 centimeters. So what it would be? F equals 120 divided by 20 upon 80. So this would be equal to, it is equal to 30 newtons. So we would reconfirm it is what? 30 newtons, 80. 120 times 20 divided by 80. It's 30 newtons. Question number 7. A long flat XY lies on the ground. A load of 120 Newton is placed on it at a distance of 0.5 meters from the end X. This is end X. The load is placed here. This is the load. This is the weight W, and this is the force which is to be applied, which is 65 Newton. In the diagram, W is the weight of the plank acting at its midpoint. So if we are talking about the length. So how much it is? So 2 meters towards right. So till here it is how much? It is 2 meters as well. So till here it is 2 meters as well. So what would I do? So I'll talk about like sum of clockwise is equal to sum of anti-clockwise moments. So what are clockwise? These are clockwise moments because the pivot is somehow here. So I would take it like clockwise moments are 120 into 0.5 plus W into 2 is equal to 65 into 4 because we have to take it till the pivot. So it is 65 times 4 minus 120 times 0.5 divided by 2. It is going to produce 100 newtons. So this is the right answer. It is 100 newtons. Now, let's talk about question number 8. The diagram shows a uniform bridge, 4 meter long and weighing 10,000 newtons. The bridge is pivoted at one end. It is the pivot point. The force at the other end gradually increases until the bridge begins to lift. What is the lifting force as the bridge starts to move? So we would see like this is going to produce which type of movements? The anti-clockwise movements. So they are going to produce anti-clockwise moments. And the weight is way here. It is not displayed, but we know he has already told about this thing like weight is 10,000 newtons and it is acting right in the middle. So it is equal to 2 meters. So I would say this is equal to 10,000 times 2 equals F times 4, which is equal to 5,000 newtons force. So the force is equal to 5,000 newtons. So the answer would be D. Question number 9. The diagram shows a wooden beam of weight 20 Newton. The center of mass of the beam is labeled M. This is labeled as M. It's here. There is a pivot at the end of the beam. This is actually a pivot point. It is displayed here, labeled here. The beam is kept horizontal by an upward force F. What is the magnitude? F. So this is going to produce clockwise moment. This is going to produce anti-clockwise moment. So what it would be, it is 20 newtons times 1.2 meters equals F times 2 meters. So F would be equal to, this is equal to 2 meters. So we would get 12 newtons. So the answer would be clear. The diagram shows a man holding a sack and a barrow stationary. Barrow means wheelbarrow. He applies a vertical force to the handle. This is the vertical force which is applied to the handle. The center of mass of the weight of the sack and the barrow are shown. This is the point where the whole weight of the body is acting vertically downwards. The wheels act as a pivot. This is actually a pivot point. What is the magnitude of the vertical force exerted? So can I say it is going to produce clockwise movement and these are going to produce anti-clockwise movements. So if we talk about this thing, so from here to here, how much it would be? 60 centimeters. So F times 60 centimeters, it is right from the pivot. So from pivot till the line of action of force, it is 60. We have to take all the way, always 90 degrees, like F and D should be 90 degrees to each other. So F times 60 would be equal to 200 newtons, which are acting somewhere here, times the perpendicular distance from the pivot, which is equal to 15 centimeters. So F would be equal to 200 newtons times 15 upon 60 is going to give me the value for force, which is equal to 50 newtons. So the answer is B. This is a tricky question. Question number 11. Here are multiple forces given in the question. A uniform beam XY is 100 centimeter long and weighs 4 Newton. The beam rests on the pivot 60 centimeters from the end X. This is the pivot point, and this is 60 centimeters away from X. Okay. The load of 8 Newton hangs from the beam 10 centimeters to the left end of the X. The beam is kept balanced. Balanced means it is in equilibrium. F acting on the beam is 80 centimeters to the left of X. What is the magnitude F? Now we would label it rest of the forces. Like for example, from here till here, it's 80. So how much it would be? It would be equal to 20 centimeters. And how much it would be equal to? Like from here till here, this would be equal to 50 centimeters. And we have a load as well. So the load is acting here, which is equal to 4 newtons. So if uh, this is 20, let's suppose, and it was pivoted at 60 centimeters, and let's suppose from here till the pivot, till the center of gravity, if it is 50 centimeters, so how much it would be? This is actually equal to 10 centimeters. Is that clear to you? Hmm? Okay. So this is equal to 10 centimeters. I label it as 10 centimeters. Now, this is the clockwise movement. This is anti-clockwise movement. The force is anti-clockwise, like 4 Newton is anti-clockwise movement. So what would I write? It is F times 20, 4 times 10, plus 8 times 50. So the value for F would be equal to 22 newtons. If we apply 22 newtons to the F, the system would be in equilibrium. Hope the question is clear to you. Question number 12. An object is pivoted at point P. A student ties a length of string to a peg. Peg means that there is something attached to the body. This could be a piece of wood as well. He pulls a string with force F. This is the force F. This is peg. This is a point which is actually the pivot. Pivot is the peg. So what is the moment? So remember this thing. Whenever the moment is to be asked, so moment is equal to force times the perpendicular distance. So what is the perpendicular distance? The S is the perpendicular distance which is making 90 degrees to the F. So it is taken to be a pivot point, sorry, a moment. So in this particular situation, the moment will be produced due to F times S. This is the way how we can write this. So this is question number 12. Let's talk about question number 13. A pair of cutter is used to cut a rope. Where should be the rope position and which labeled point should be has the position to produce the greatest cutting force? So in order to make it easy, the distance should be as far as in order to produce the smallest force. So the hand's positions must be at S in order to make it easy to cut it off. Because if we are going to apply force at R, it would be difficult for us to handle it. So in order to make it easy for us to cut, the distance should be as far as it is. As the situation, like for example, if there is a door and we want to open it, so there is a door knob here. Otherwise, doorknob would have been here because the perpendicular distance is small, so the force applied must be very large. Now, in this particular situation, if the doorknob is very large distant, so the applied force should be very small. So it is easy. That's why we have chosen S. So hand position should be at S, and the rope should be placed at Q. And what is the reason why we have placed it at Q? Because this is the smallest distance from the pivot. This is taken to be a pivot point. So this is the smallest distance. For smallest distance, the force becomes higher. According to formula, let's suppose if it is F1 D1 and this is F2 D2. So if F1 D1 equals F2 D2, if the perpendicular distance on the right hand side is larger, the force required to cut the rope would be smaller. And if the perpendicular distance from the pivot is smaller, then the needed in order to cut the force is automatically bigger, which makes it easy to cut the rope. So that's why we have chosen option number D. Okay. Question number 14. In this question, a uniform rod XY has 2 Newton weight, has a length of 80 centimeter. Now this is 80 centimeter. It means weight would be somewhere acting here, which is around 40 centimeters on either side. This is 40 centimeters on either side. Now a weight of 5 Newton is suspended from the pivot from end X. So the thread is over here. It means this point is taken as a pivot point. So this is taken as 5 times 20. It is going to produce anti-clockwise moment, and this is going to produce a clockwise moment. So this would be W times 20 as well. So which means W would be equal to what is the distance of the 6 Newton load? Okay, we have to do it again. We have to interpret it again. Just one second. In the question, he's saying like we have 2 Newton force, 2 Newton weight, which is acting here. This is 2 Newton load acting here, has a length of 80 centi. So this would be 20 from the pivot and rest 40 till the end. So this is 20 centimeters. A weight of 5 Newton is added already. A student hangs 6 Newton weight on the rod so that it is in equilibrium. What is the distance 6 Newton weight from the end X? Now we have to see like what are the clockwise and anti-clockwise moments. So let's talk about it. So what are the clockwise moments? So clockwise moments are 2 newtons times 20, which is equal to 40 Newton centimeter. Okay, what are anti-clockwise moments? So anti-clockwise moments are 5 times 20 centimeter, which is going to make it 100 Newton centimeter. It means anti-clockwise moments are bigger as compared to clockwise moments. So which means like 60 Newton centimeter clockwise moments are required. We have 6 Newton force and it must be applied like 6 Newton must be applied at 10 centimeter from the pivot in order to make it 60 Newton centimeters. So it must be applied somewhere here. So it is 6 newtons. It is 10 centimeter from here and from the pivot. It would be equal to how much? It would be equal to 30 from here till here. So that's why the answer would be 30 centimeters. No? Should I explain again? Okay. If we see this question, the clockwise moments, just 1 second. These are the clockwise moments which are being produced here. So I have written them 2 times 20. This was the perpendicular distance from the pivot. It is 2 times 20. Fine. So this is going to give me 40 Newton centimeter. What is the rest of the moment? Like 5 Newton times what? 5 Newtons times 20 because it is from the pivot. So it is 5 times 20. It is going to make 100 Newton centimeter. So it means anti-clockwise moments are 100, clockwise moments are only 40. It means there must be further 60 Newton centimeters clockwise in order to make it in equilibrium because clockwise must be equal to anti-clockwise. So in order to produce 60, the 6 Newton load is available to me. So 6 Newtons must be at 10 centimeters from pivot in order to make 60 Newton centimeters. But examiner has asked for like how much it would be from end X. So from pivot, it is actually 10, but from X, it is how much? It is equal to 30 centimeters. That's why I have taken it 30 centimeters. Hope the situation is clear to you. Let's move on to the next question. This is a good question. A wooden plank rests in equilibrium on two rocks on opposite sides of a narrow stream. Three forces P, Q, and R act on the plank. How are the sizes of the forces related? So for equilibrium, sum of moments must be equal to zero. This is the first condition. And the second condition is sum of forces must be equal to zero. So what are the, because this is a system which is actually stable on two stones, so obviously it is not going to rotate. So we would go for the next option. So what are the two forces acting upwards? It is P plus R. And what is the total downward force which is acting, which is equal to Q? So sum of the upward forces must be equal to sum of downward forces. Luckily, we have only a single force Q available. That's why P plus R would be equal to what? Q. So the answer would be B. Yes. Okay. Ji. Question number 16. A ball, a balloon, and a mass are attached to a rod that is pivoted at P. The balloon is filled with helium, a gas less dense than air, so that it applies an upward force on the rod. The rod is horizontal and stationary, which action causes the rod to rotate clockwise. It means that the clockwise movements must be greater than anti-clockwise. So over here, what are the clockwise movements which are being produced right now? So this is 30 centimeters, and this is the force applied by the balloon. So the clockwise moments are FB times 30 centimeters. What are anti-clockwise moments? So this is the weight. So weight times what? 20. Why I'm not taking mass? Because this must be a force which is being multiplied by the system. So they are right now in equilibrium. So FB times 30 is equal to W times 20 centi. So what is FB in terms of W? So this is 2 by 3 W. Okay, move both the balloon and mass 10 centimeters to the left. If I'm going to shift both 10 centimeters to the left, so what it would be? For example, in this option number A, so FB times 40, because we have shifted it here in option A, 40 is equal to W times 30. So what was FB? FB was 2W upon 3 times 40 is equal to W times 30. So if we see, the left hand side is going to produce what? Left hand side is going to produce 0.6 times 40 W, like 0.66. 0.66 times 40. It is going to produce 13W equals 3W or 30W, which is not the desired answer because the right hand side, like the anti-clockwise moments, are bigger now. So we would go for option number D. So option A is not taken to be a correct option. So if we just take option B as an option, and we would start solving it, so option A is taken as wrong right now. So if we talk about option B, so if we move both balloon and the mass to the right, so what it would be? It would be FB times 20 is equal to W times 10. So if FB is 2 by 3W times 20, would it is going to produce the same effect? It is 40 upon 3W, which is 10W. So it is equal to 40 upon 3 is equal to how much W? 13.3. Yes, this answer is right because this was actually producing a clockwise movement. This FB was producing a clockwise movement. So it is producing clockwise bigger movement and anti-clockwise smaller movement. So this is anti-clockwise movement, this is clockwise movement, and he has asked for like which is going to produce to make it rotate clockwise. So the answer would be what? B. So B is taken to be our right answer. Is that clear? Now let's proceed to some other questions except these pivot ones. Let's suppose this is a question. The diagram shows a uniform bar of length 120 centimeters and weight W. The bar is pivoted at a point 40 centimeters to the left end of the bar. The load W by 2 is suspended from the right hand end of the bar. A downward force F is applied to the left hand end to keep it in equilibrium. What is the magnitude of force F? So this is W by 2, this is W. So we have to give our answer in the terms of W. So what are the clockwise moments? Anti-clockwise moments are anti-clockwise moments are equal to F times 40. This is 40 actually. And what are the clockwise ones? It is clockwise moments are equal to W times 20. This is 20 centi. And what it is? It is equal to 80 centimeters because from here to here it was 40 and rest of it would be 80 in order to make 120 centimeters. So this is equal to 80 centimeters. So plus W by 2 times 80 centi. So it is 20W plus 40W. It is going to make 60W. On the left hand side, we have F times 40. If it is in equilibrium, so F times 40 is equal to 60W. So 60W upon 40 is going to make it 3 by 2W. This is how it's done. The answer will be C. Let's do some more questions regarding some favorite ones. Okay, this is actually a good question. This is a tricky and tough question as well. This is taken to be the last question of this one book now. Okay, 20-meter long uniform bridge of 100 kilonewtons is supported at each end by a pillar as shown. The pillar exert forces T1 and T2 on the edge of the bridge. What are the values of T1 and T2 when a van of 24 kilonewtons is on the bridge 5 meters from the left hand pillar? So the system is in equilibrium. So it means sum of all the forces must be equal to 0. So T1 plus T2 would be equal to 24 plus 100 kilonewtons. So can I say T1 plus T2 is equal to 124 kilonewtons? Yes. So this is the first equation. We have two variables, so that's why we have to make two equations. Now it's our own choice which point we have to take as a pivot. So let's suppose if I'm going to take this as a pivot. So examiner is saying like the van is 5 meters from the left hand pillar. So this is equal to 5 meters. So can I say this is going to produce clockwise moment? This is going to produce clockwise moment and this is going to produce anti-clockwise moment. So clockwise must be equal to anti-clockwise. So clockwise are 24 times 5 plus because this is center of gravity. So center of gravity is exactly in the center. So this is 100 times 10. What are the anti-clockwise moments? Anti-clockwise moments are T2 times 20. Why we are not taking as T1? Because the line of action of force is passing through pivot. So T2 would be equal to 24 times 5 plus 100 times 10 divided by 20. So T2 is equal to, let me solve it. It is going to produce 56. So T2 is 56 kilonewtons. We know like T1 plus T2 is 124. If T2 is 56, So that would be equal to 124 kilonewton. So T1 would be equal to 124 minus 56. It's going to give what? 68 kilonewtons. So the answer is C. So that is all for today. Take care. Thank you and Allah Hafiz.